Okay, an example question for negative binomial. So we have Philomena practicing her piano scales. The probability she completes a scale correctly on any one attempt is 0.4. She continues practicing until she has completed 4 scales correctly. So if x is the number of scales until she's completed 4 correctly, then x is negative binomial, r is 4, probability of success is 0.4. And we want the probability that x equals 12. So you can just plug into this, which is given to you in your formula book. So this is x, so x minus 1 is 11, r minus 1 is 3, and then p to the r will be 0.4 to the power 4, and then x is 12, so 12 minus 4 is 8, so 0.6 to the power 8. I'm assuming you're fine, I'm sure you're fine with this actually, but that notation for 11 choose 3 is interchanged with that in these statistical formulae. You're not going to get it confused with a vector while you're doing statistics, it's not too much of an issue. And then you can just whack that into a calculator and you end up with 0.0709. Alternatively, see, I'm probably a bit, I don't know if you'll find the same thing. I find it easier not to plug into that formula because I find that formula just confuses me slightly. So probability x equals 12. I know that I want 3 on the first 11. So that's 11 choose 3. Or you could write that like that. So this is your binomial bit. 0.4 cubed, 0.6 to the power 8. So it depends how comfortable you are with that binomial formulae. So that's that she does 3 scales correctly in the first 11 scales, so exactly 3 correct. And then we want the 4th one to be on her 12th scale. And I find it easier to use that logic than plug into there, but totally up to you with that. Alex, I've got a feeling you're going to be looking at me like, what's she doing when you see that one? But yeah, that's kind of your logic behind the formula. And again, if you're unsure about that bit, I'd like you to understand that. So if you're not sure about that bit, please ask. So part B, we want to find the probability she completes her 4th scale correct on her 10th attempt. So we want the probability x equals 10, given that the first is correct. And a bit like with the geometric, these given that questions in the negative binomial, you just need to think about what's happening. So you don't want to be using conditional probability formulae for these. If the first one is correct, then in the next 9, she wants her 3rd one to be on the 9th trial, on the 9th scale. So if we change the variable, if I let y be negative binomial, and now I want 3 successes, probability of success is still 0.4, and you want the probability that y equals 9. And that will do that for you. So it has no memory. So you can just ignore that first one and think about the next 9 trials. Plugging into this formula, you get 8 choose 2. 0.4 cubed So I find this way more difficult than using the binomial. And then 0.6 to the power of 6. And that gives you 0.0836. It's a little bit of a fiddly formula, that one. Or you could use your knowledge of the binomial distribution and say, okay, I'm sorry, the background noise today is just ridiculous. My printer's joining in now. So if y is 9, we've had 2 in the first 8. So that's 8 choose 2, 0.4 squared, 0.6 to the power 6. And then I didn't actually send that to the printer, times by 0.4, which gives you the same as this. To here, okay? So any questions, let me know. I'll give you a few to do, and we'll have a look at some distribution shapes as well, I think.